Hello everyone, welcome to my channel. Today we're tackling a classic exam problem which focuses on plane stress analysis. So in order to solve such a question, we first look at what is given to us. We need to extract our data correctly. Let's focus on the x-axis first. We see that the arrows are pulling away, they're pulling outwards. So that means that the box is in tension since it's pulling away. So normal stress in x-axis is positive 17 megapascal. Tension is positive. And then if we look at the y-axis, we see that the arrows are pointing inwards. They're pushing in. So that means that it's in compression. So when we have compression, we have a negative sign in our normal stress, so negative 55 megapascal. The problem also states that the maximum in-plane shearing stress is limited to 82 megapascal, so we keep that in mind. And in order to solve for the largest value of half xy, we will use our trustworthy radius formula, which is given over here. And what do we know in this formula? We know our normal stresses. So we plug it in and we get, make sure to add all the signs because that changes a lot. And what else do we know in this formula? We know that our Tmax is limited to 82. So overall, what do we write? We write that our R, our radius, equals to square root of 62.5 squared plus our unknown, what we're trying to find. And if we square both sides, we get we remove the square root. And if we solve for this, equals to 53.08 megapascal. Do these calculations on your own in case I did it incorrectly. And let's move on to part B, which is finding the principal stresses. What are the principal stresses? What are we trying to find? We're trying to find the normal stress, the maximum normal stress. And we're also trying to find the minimum normal stress. These are called the principal stresses. So how do we find those? There's formulas for these. So let's do it. So the maximum normal stress is given by normal stress in the x-axis plus y-axis over 2 plus our radius formula, which is given by this big thing. That's kind of ugly, I'm sorry. And we can summarize this by writing it as the average normal stress plus the radius. So we don't have to write all of that. And then for the minimum, same exact thing. Literally copy paste it. But this time it's minus. So it is the average normal stress minus the radius. That's the only difference. Maximum, minimum It's the sign that changes, that's it. So to simplify our life, what we do is, let's just find our average. It's the same for both. So we know both of these values, 70 plus minus 55 over 2, and that's 7.5 megapascal. So now we plug this in for both. Let me make some space. So that would give us 7.5 plus the radius, which was, is it 82? Yeah, plus 82, which gives us 89.5 megapascal. And for our minimum, we write the same thing, 7.5, which is our average, minus 82. And that gives us minus 74.5 megapascal. And that's how you solve it, guys. It's actually quite simple. Thank you for watching.